So this video I just wanted to make was about Huffman coding. So Huffman coding is a method of compression. So it's a lossless compression technique, and it's involved in compressing usually text, and it's in the GCSE. So it would be good if we could learn how to do it. So we're going to compress this phrase here, which is huff space and space puff. And the first thing we want to do is to do a frequency set for each of the letters. So I'm just going to cross them off as I do it. So H, we've got just one. There's one H here. Can't see any more. So going to the next letter, which is U, I've got two of those. So write down two. And then I've got F. Well, there's 1, 2, 3, 4 Fs. I'm going to write down 4. Then I've got space. So I'm just going to call that SP for now. And I've got two of those. Moving to an A for the and. There's just one of those. And an N. I think there's just one N. And the D. I think there's just one D. And then finally, the last one we haven't done is P. And there's just one P as well. So we've made a frequency chart of how many times each character appears in the sentence that we want to compress. So then the next thing that we want to do is to create a tree out of this. So we're going to start with the lowest numbers. So I'm going to start at the top with H, and I'm going to put it here. I'm going to put a 1 underneath it because it's H. So I'll cross it off there. We've done that. So the next one that's a 1 is A. So I'm going to put A here. Let's put a 1 under that. Then I've got N is a 1. And D is a 1. And P is also a 1. So I think that's all the 1s. So then U next is a 2. And SP for space is also a 2. And then finally we've got F, which is a 4. So we've used up all of the letters and we've written them in a line, lowest on the right, highest on the left. So then the next thing we're going to do is connect them together. So when I connect these two 1s, I end up with a 2. So then the next lowest I'm looking for, so I could connect these two 1s together to make another 2. And then I've got a 2 and a 1 here, or I could connect that 2 to this 1 to make a 3. If I connected those together, I'd get a 4. So 3 is the lowest. So I'm going to go with this one, like that. So I've connected those together to get a 3 because I've got 2 U's and 1 there on the P. So then if I connected this 2 to the 3, space to this, it'd be 5. If the 4 to the 2 would be 6. So the lowest one is 4. And that's connecting these two together. So I'm now up to 4. So I've added those two together. So now I've got a 3 and a 4. That would be 7. I've got a 3 and a 2. That would be 5. And I've got a 4 and a 2. That would be 6. So 3 and 2 is 5. Join those together with a 5. So then 5 and 4 would be 9. 5 and 4 here would be 9. So I'm going to connect these two together to make 9. And finally, I've got my F. I'm going to connect that to the 9 to make 13. And just a little check, how many characters do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the number at the top, 13, should be the same as the number of characters. And if it's not the same as the number of characters, then we've made a mistake somewhere and we need to come back and have another go. When we've done that, then we usually allocate a binary number to each branch. It usually starts on the left as 1. So each branch gets a 0 or a 1, just like this. So every time we've got a branch, we get a 0 or a 1. And when we've done that, we've finished the actual tree, but we've not actually done the code chart yet. So the code chart, we're going to end up with, if I have a code for H, let's just write the code chart on this side. The code for H would be 1, 1, 1, 1, because that gets me down to H. So in binary, that's 1, 1, 1, 1. Code for A is going to be 1, 1, 1, 0. 1, 1, 1, 0, just like that. Code for N, 1, 1, 0, 1. The code for D is, let me just write D down, 1, 1, 0, 0. And you should be able to see that each individual letter has got a unique representation in binary. So if we come on and do P here, it's 1, 0, 1, 1. And U would be 1, 0, 1, 0. And then space would be 0, 0. And finally, F is just 0. So that is our code chart for the Huffman code tree for Huff and Puff.